Hi, I'm an old guy and I do maths. The question in front of us today is what is the equation of the line perpendicular to the tangent to the function of x equals root 4x plus 9 at x equals 4? Now, I've done some preliminary work here, and I'm going to do this problem in three parts, and I'm just going to talk you slowly through this. I'm going to do more work than is necessary. You don't need to do these drawings. Um, if you're comfortable with the methodology, you can work this out without drawings. But um, if I draw the graph of the original function, it's a square root function, and it looks something like this. And what I've done then is I've taken x equals 4 and put it into this function here. So I get the square root of 4 times 4 plus 9, which is the square root of 25, which is 5. And that gives me my point here, 4, 5. The line perpendicular to the tangent at that point is here. And there are some bits of information that I get from this. It is highly likely that the gradient is negative, even though this is an imprecise drawing. The gradient of this is positive. This tangent will therefore have a positive gradient. And the gradient at 90 degrees to that will be negative. Also, the y-intercept of this is going to be somewhere north of 5. It's going to be greater than 5. It's up here somewhere. So, it could be 20, 30, something like that. Who knows? We will know at some point. Okay, now, that's the first step. I've located the point and I've given myself an idea of what it is I'm looking for. Now, the next thing that I'm going to do is I'm going to figure out what the gradient of the tangent is. So just bear with me. Now, we're looking for the gradient at x equals 4. Now, for that, we need the differential of our original function. Now, function of x was root 4x plus 9, or, which makes it easier, 4x to the half. 4x plus 9 to the half, I beg your pardon. So that equals that. Now, you can use the chain rule to differentiate this. And when you do that, the differential of this is as follows. There we are. That is the differential. Okay, so from there we can find the gradient at x equals 4. All we have to do is put in the number 4 and we'll get the gradient. So f prime 4 equals 2 over 4 times 4 is 16, the square root of 16, over plus 9, sorry. So it is 2 over the square root of 25, which equals 2 over 5. Okay, now that is the gradient of the perpendicular line. Sorry, no, that is the gradient of the tangent. Get it right. That is the gradient of the tangent. So what we have is we have the gradient of this line here. Now we're going after the gradient of this line. Now, the gradient of the line that's perpendicular, the normal, if you will. So if the gradient of the tangent is equal to 2 on 5, the gradient of the normal, or the line perpendicular, is equal to negative 1 over 2 over 5. So it's m, and negative 1 over m. That's the relationship. Now, what does that give us? Very quickly, negative 1 over 1 divided by 2 over 5 is equal to negative 1 over 1 times 5 over 2, which gives us negative 5 on 2. That's our gradient. So now what we have is we have the gradient of the normal, the perpendicular line, and we have 2 points, a point rather, 2 coordinates, an x and a y, that it passes through. Those points are 4 and 5. Right, so that's part 2 over. Now, what we've got to do is we've got to take that information and put it into a linear equation and find all the elements. Now, here's the result. We're working on the basis that our linear equation is in the form of y equals mx plus c. We know that our y coordinate is 5. We know our gradient is negative 5 over 2. We know that our x coordinate is 4. And we are looking for c, the final piece in the puzzle. So 5 is equal to negative 10, negative 5 on 2 times 4, plus c. A little bit of rearranging, 5 plus 10 equals c equals positive 15. We know the gradient, we know the y-intercept now, we know everything. Now, if we wanted to leave it like this, that would be perfectly fine. However, the question as it was put to me was a multi-choice question, and one of the answers was this: 2y plus 5x equals 30. So this is how we get to there. This is actually technically correct. That's a good answer. What we do to get to here is we multiply this whole thing by 2. That gets rid of the denominator. And we rearrange it so that we have 2y plus 5x equals 30. And that, and also that, also answers to our question. These are forms of the equation of the normal to the tangent on the curve y equals the square root of 4x plus 9 at x equals 4. Thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I will see you next time. Bye.